Okay, welcome everyone. This is our most likely the last interchange for this year. And we have a list of topics. Let's skip over the new attendees since we have limited time. Let's directly jump on to the first topic, and as people join in, I'm recording, so basically we can go over the recorded version. Let me share my screen. So can you see my screen?
Yep, yes.
Okay, cool. So we have a pretty full whole 40 minutes today. We're going to go over some of the catalog installation work that I have been doing. Then we have a couple of more presentations. So let's see. So basically, this is the one I have been working on from past few weeks on catalog installation, our OpenWhisk catalog. We were using shell scripts. I have a PR open, which is ready for merge. And so now I have changed our Travis job to install OpenWhisk catalog using the Whisk deploy manifest instead of the shell scripts. The shell scripts are still there. I didn't want to delete them as of now, but once we merge this and we are ready, and if basically no one is using, then we can delete the shell scripts. So I quickly wrote a small shell script. This is the Whisk deploy invocation for all of the packages in the catalog. And as you see, it's a very simple Whisk deploy command. And then basically just feeding in the manifest in each packages. And the way it is structured is each package has its own manifest.yaml. And we are just feeding that manifest into the Whisk deploy. So it's very easy. It's Travis has it. We are running all the tests that we have been running, and they all look pretty good. So I'll not take much time, but I mean, it's all in PR. The Travis builds are there. So we can basically refer to the Travis logs. So let's see, let's go over to the next. So Moritz, are you there?
Yes, I'm here.
Okay, cool. Do you want to start your presentation on the API gateway?
Yeah, sure. I will just share my screen.
Yeah, let me unshare.
Okay.
Yeah.
Okay, do you see it?
Yes, I can see your screen.
Okay. So yeah, hi everyone. So this is about a work in progress which allows the API gateway to serve content. So the goal is for the API gateway to serve content in the place of web actions. So this will provide a way for web actions to bypass the response size limit of, I think it's 1 megabyte in OpenWhisk. So how does this work? So basically, this is like what a web action would look like in Node.js. So I have like 3 response headers which control the feature. One header which indicates where to fetch the content from. One header which is like a stringified JSON specifying a list of request headers for the request to the content that we want to serve. And then a list of headers as well for the, an object of header for the response, and this would override the response headers returned by the URL specified here, which allows, for example, to change the content type or the cookies or whatever needs to be done. So this is how it looks internally. So basically, when a client makes a request to the web action, the API gateway, instead of doing a simple proxy pass, it will forward the request using the Nginx Lua location.capture, which does a sub request to the controller, and this would allow to act on the response. So basically, when the web action returns, the API gateway now has the ability to read the response headers and act on it, like by doing an internal redirect. So if the response redirect URL header was set by the web action, we can now do an internal redirect using Nginx exec, so the client is not involved, to actually the URL that we want to serve the content from. And if the URL was not set, we just simply respond with the web action response. So some security checks that I have done as well is just to be sure that the action doesn't point back to the API gateway. Like, for example, just to be sure we don't want it to invoke other action that way, and also that the redirect URL it uses doesn't resolve to a private IP, so that it doesn't access the cluster internally. So I would just do a quick demo of this thing. Do you see the? Okay.
Yeah, it's slowly coming in.
Do you see the editor on the terminal?
I think I see the editor, but it's everything is blank.
Oh, okay. Wait, I'm not sure how.
Same here.
Okay, right. How does it work? Maybe I need to stop share and share again. Okay. Do you see it now?
Yeah. Now I can see.
Okay. Yeah. Perfect. So yeah. So I have this. This web action, which is basically. So now it will return the header to tell the API gateway to serve a file which is stored here, and this file is above 1 megabyte, and it's just an image. So I just create the action, and then I invoke it. It's a web action, so I just do a curl, and I output it to a file. So here we can see that it just fetched a 1.7 megabyte picture. I can open it. Oh, sorry. And yeah, we can see that it downloaded it. And then just as a second kind of demo, just to see that the request headers and response headers are set, I will just call like an endpoint which is just echoing back my redirect request. So just update the action, and yes. So yeah, so here we can see in the responses that the content type I set was overwritten because this is JSON basically, but now because I've set image JPEG, I just set it here. I have also some response headers which are set here. And here in the payload, I can see the echo of my request, and I can see the headers that I've just set here. So yeah, basically that's it. If you have any comment on that feature, I mean, I would like to hear what you think about it. Any questions?
I remember that web actions have the ability to send a redirection code, right?
Yeah, exactly.
So what's the difference between returning a redirection code and this feature?
So by returning a redirect code, I mean, by doing a normal redirect, the client is involved, meaning that if the web action returns, like it will return like a status like 301 or something like that, and with the URL the client needs to redirect. But maybe the client doesn't have like the credentials to access that content, or maybe the web action wants to change the content type or the cookies or do some other type of processing. So because this is internal, like this feature, it's like the API gateway which will fetch the asset and return it to the client.
Oh, I got it. Thanks.
Okay.
Yeah, this is very cool. Yeah, very cool. I think you mentioned it, but what's a tangible use case for the response header? I grok everything except what is like you have a real scenario for the response header, because once you do the request to something and a picture, that thing should put the right response header, like the right content type. What will be? Do you have a use case in production?
So for example, like we're one of the teams in Adobe, like so if you serve content from GitHub, for example, like I think if I understood correctly in GitHub, like the content type is not set properly.
Octet or something like that.
Yeah.
Okay, cool. Okay, to fix those corner cases that they're not, those things are not working as you expect. Okay.
Yeah, cool. Exactly.
Any security risks for operators or vendors that are deploying this in production that will bite them?
So yeah, one of the thing was that I mean, we want to avoid that they redirect to inside the cluster because it's the API gateway now doing the request. It would have access to the cluster. So I'm just resolving basically the redirect URL, seeing if it's not private, if it's
blacklist,
not redirecting to the API gateway. So I've really put some thought into that. I think it should be safe. Like I will, of course, we do some checks and that it reviewed more, but yeah.
Okay. Is this a PR done, or is this a proposal, or?
So for now, this PR is internal to our API gateway, but I wanted to share it like into the OpenWhisk API gateway. So I didn't do a PR yet, but yeah, I just wanted to have your input before.
All right.
Thank you.
Any more questions? All right, so let's move on to our next presenter. Aris, are you there?
Yes, I am.
Okay, cool.
Okay,
you want to start by sharing?
Yeah, start by sharing my screen. Do you see my screen now?
Yes.
Okay, good. Thank you. Okay, let's get started. So this is something I got from a project I'm working on. I needed to pass information from a trigger to an action that was invoked by the rule that associated the trigger with the action. But I needed to pass information pertaining to scheduling that was basically was transparent to the function in the action. and it needed to be passed on from the rule to the action to any other actions that needed to be invoked by that action as well. And then I started thinking what I could do with this. So I'm working on implementing a small portion of this, but I'd like to bring this to discussion to get some perspective of the viability of this, which I think is significant to OpenWhisk. So I named it shared context. What is a shared context? Basically, we're talking about a piece of information that is automatically propagated over invocations along the call tree, okay? The context is not part of any invocation parameters, so it's transparent to action code. The content is still available to the action code during invocation, similar to other OpenWhisk facilities, such as the activation ID. So if activation ID is currently available through environment variable, I guess we could use the same facility. Otherwise, we could use whatever new facility is provided for this. It can be explicitly added to at every invocation. A client that performs the invocation may choose to add more context, and that's added and guaranteed to be propagated from that point on. And it's also persisted in the activation records of the invoked actions and triggers and combinators and all that. So here's an example. You can see a kind of a call graph that includes both synchronous, asynchronous, and rules. And the root invocation has a context with the label A. Now, from that point on, A is guaranteed to be propagated to all the invocations. Thereby, as you can see, A essentially identifies the entire flow, the entire flow that spawns from that invocation on. Now, at each level, each subsuing invocation, the client may choose to add more context. So it adds context B, or context C, and then D. And from each point, context is further propagated. As you can see, this mimics some very well-known principles in local programming of associating data with the context of execution rather than one specific invocation of it. This entire flow has a common context of invocation execution that was generated at the root invocation. So in Java, you can see examples like thread local storage. In Scala, you're probably familiar with the implicit, where we associate information with the context of execution, and thereby it is guaranteed to be passed on. So why am I wasting your time in this discussion, right? Why am I bringing this? What is this shared context good for? Well, it turns out it's good for many things that can advance OpenWhisk significantly, I think. For one thing, distributed tracing and debugging. If we have a context, you can just identify all the actions. If we inject the context in one invocation, any other invocation that results from the function that we invoked are also labeled just the same. So this identifies a whole trace. So imagine just sitting down in front of an OpenWhisk console and just turning on tracing, and voila, you suddenly get a view similar to this. This is Epsagon. This is a third-party offering on top of Amazon Lambda. You can see here an API gateway that invoked a Lambda function that then invoked a service, and that then invoked another service that triggered an event, and other Lambdas, etc. We get a whole view, a feeling of the application behavior rather than specific and disparate invocations. Similar concepts, we can do profiling on top of tracing. We can have polyglot debugging. You can do step into function when the function that you're invoking is something that's invoked asynchronously or over a trigger or the regular synchronous invocation. Just because the context, we can pass in the context outside the function some flag that says the interactive debugging. We can do distributed transactions by passing the transaction identifier in the context. we can do extended scheduling. By coloring or identifying specific flows, we can apply resource limits, rate limits, distribute time budget, specify quality of service. I can say invoke this function at quality of service, at the gold quality of service, and in another invocation, invoke this function in a silver quality of service. We can do access control, again, at a flow level rather than a full tenant level. Very fine-grained. We can do federated computation. Stack trace and unified console are very, I think, very appealing analogies. As many of you are working in JavaScript, in Java, in Python, whenever an exception is thrown, you get a stack trace. In the line of the function A that was called from a specific line in function B that was called the specific line of function C, etc. We don't have that in OpenWhisk, because all you can have is the isolated stack trace in the specific action that was called. You can't get that for a full stack, but with a federated context, of course, with a shared context, you can easily do that, because you pass the stack frames in the context or refer to them. A unified console, whenever we write a function in a local machine, a function that calls another function, and each function dumps something to a console or to a log, and you print them, you get the woven behavior of the entire application. However, you can't, again, in OpenWhisk, you can't get that, because those are separate activation records, each one with its own separate logs. Okay? But if we pass a shared context, we can redirect them as they run into a common console. And then there are more stuff like causality inference. But the bottom line is, I think having this shared context, this analogy of a thread that we can associate information with, okay, and then do all kinds of stuff that we're used to having on a local machine, having at the cloud level, takes us one step closer to the vision of serverless, which is realizing the cloud computer. So here is some proposal how to implement, how I'm proposing to implement this shared context, okay? The example on the top, whisk action invoke, as you can see, I provide the parameters at the invocation, but I can also add key values that are injected into the context. The difference between the parameters and the context, parameters affect only the function that I'm calling. A context sustains all the ensuing invocations from the function I'm calling forward, and is propagated with them. Okay. So a client invokes an asset. I'll do this quickly because I think I don't have much time. The idea is that a client can be standard sequential code, can be a function in itself, an action in itself, invokes another action, or a trigger. Okay, that's the invoked. And during that client may have a context by itself. That context, when the client performs the invocation, that context is transparently copied by the invocation code to the invoked. When you ask how, I would say, if in most cases when a client does invocations of OpenWhisk, the client usually uses a client library. We have that in OpenWhisk for JavaScript, for Go, for Python. So when doing the invocation in the invocation library, it detects whether the client already has a context, and if so, it copies that context into the invocation and propagates it forward. Now, as you can see in the invocation here, there is an addition orange square. So that could be an explicit context that the client chooses to inject additional context. Okay, as for example as matching the example above. So this is an extension. The whole injection of the context requires some extension to the OpenWhisk REST API, where we add an additional parameter of context. Now, invocation, the library, the client library that we use will use that extension in the API and add the context of the client if it exists, and will also allow the client to specify additional context for the invocation. Then that context is passed on to the invoked as an action or as a trigger. If it's a trigger, then all the actions that are invoked by rules associated with that trigger get the context as well. Again, guaranteeing the propagation. Once the context is received in the actions, it becomes the context of those actions as well. Okay, and again, it's outside the parameters. The application code is unaware. On the right side, I proposed some structure of kind of if you're familiar with the tree set in Java, it's a key value structure that allows both key lookup, but also maintains an order of the entries. Why is that? Because the order actually reflects the order in which the entries were entered into the context, well, in consequent invocations. And so that could represent, for example, stack trace or other stuff, and the order is important. The context can also be extended to be integrated with end services that are invoked. For example, in the case of distributed transactions, we could map a distributed transaction identifier to local transactions that are in the database services that we're invoking. Relation to Composer, I've been asked.
Two more minutes.
Okay. Okay. So I'll skip the whole. There is I've been asked several times what's the relationship between shared context and conductor, but the bottom line is that essentially those are orthogonal mechanisms. One is a methodology for orchestrating flows, and in particular in implementing the functional aspects of the application by embedding it into combinators. And the other is a mechanism for transparently sharing data over the call tree, typically for handling non-functional features, non-functional aspects of the application, such as scheduling or access control or distributed transactions and so forth. I checked various offerings of other well-known competitors, and it turns out only one of them, Amazon, implemented actually the spec that I'm proposing. Through a tool called X-Ray. They have an offering called X-Ray where they actually implemented what I'm proposing in this presentation for Lambda. But however, they restricted the implementation specifically to tracing. In others, again, they have distributed tracing different solutions, but none seem to have kind of a generic context. So moving on to conclusion. So a shared context is propagated along a call tree. It can enable many advanced features in serverless. It's simple to implement. I didn't get to discuss all details. You get that in the backup. I can share the presentation later. And it's independent of Composer and complementary. So there could be some mutual benefit here. And there is no clear evidence of generic shared context in the competition yet, but there are several domain-specific applications that already exist. That's it. Rest is backup. So questions?
So if you have any questions, I've got 4 minutes on Zoom. I just got a notification. So we can continue until for 4 hours. So any questions for us?
Just a quick comment on the relationship between conductor actions and context. I think they're not orthogonal. I think it's more subtle than that. So it's true that we've been describing conductor actions as a mechanisms to manage the control flow, but it provides the basic capability of managing context. So the key difference that's being exposed here is that with conductor actions, we've specifically chose not to add an additional API or modify the REST APIs, etc., to support the context as a separate namespace from the parameter object. So what we do with conductor actions is we manage the context as a parameter that has a special name. But conductor action can make it possible to hide these special parameters to the actions being invoked. So the properties that I think you're looking for here, which is this context is hidden from the actions by default, you can perfectly do that with conductor actions. So I mean that's again not saying that this you can do exactly what you describe with conductor actions, but I think there's a very, very significant overlap as opposed to saying that these two things are orthogonal. And I think the key question has been whether we want to support side channels to pass and manage parameters. And for instance, I'm convinced that environment variables are good to pass in identifiers like activation IDs. I'm not convinced you can use environment variable to pass in a stack of arbitrary size and structure.
Okay, so can I address some of the issues now? Okay, so I'll do that from the end to the beginning. Okay, so I'll start first with the environment variables. I know there is some discussion about keeping the current structure of using environment variables to share data, and I think there is some initiative to move to other formats. But my point is that it doesn't have to be maintained. The context itself doesn't have to be maintained in full in memory. Okay, it can be, but it doesn't have to be. For example, I could keep a key I could keep a key to an external storage service such as Redis. Okay, and store the context there, and then I'm not limited. And I'm not that tightly limited on size. Okay, so this is not, it's not about, I think that the specific format in which the context can be stored, what I was stressing is just it should have equal visibility to the OpenWhisk activation ID. As to the specifics of the mechanism, I believe this can be quite easily mitigated. Okay, the size limitation. Now, as for the relation to Composer, as far as I know, two things actually.
Yeah. Erez, we're gonna have to cut this off and move to the dev list. We have 2 more topics to get through.
Yeah.
Okay. So we can take this discussion offline. Okay.
And can you send out your slides on the dev list, and yeah, we can take the discussion from there.
Excellent.
Vincent, you there? Vincent?
Yeah.
Okay.
Yeah, sorry, I'm on mute. Yes, I would like to introduce the Jenkins pipeline for our OpenWhisk. So can I share my applications? Yeah. Okay. I see the slides I'm showing now. It's only one page, which is more straightforward. First, I will great thanks to Adobe company who has donated us 3 virtual VMs for our infrastructure, and which has been approved by Apache communities. And there is a wiki page over here thanks to Carlos, so you guys can check out that, and we're able to use all of them. You can check out the configuration over there as well. Well, why do we considering kick off the Jenkins pipeline job for OpenWhisk? We already had Travis CI, and which has been working their things almost day one of OpenWhisk. So to me, this is definitely not a duplicate. We're going to try to avoid that. Travis still doing Travis' job, and Jenkins pipeline will become a necessary supplement. And for example, our Travis CI is definitely focused on the standalone, deploy everything on one virtual machine. We build, we deploy, we test, we're doing everything on the standalone mode. What we target Jenkins' job is going to do is Jenkins will focus on testing some distributed environment of OpenWhisk. For example, we deploy like controller on one VM on one node, and invoker 1, invoker 2 on different virtual machines. So we're trying to test, I think, definitely focusing on the distributed deployments. And I have already set up some local Jenkins configurations with the OpenWhisk repository. Of course, it's my fork. And we can go by stages. So the first step, I would like to implement some Ansible deployment. For example, we have already had 3 virtual machines. I would like to deploy one invoker on, for example, VM2, one invoker on VM3, and all the other microservices on VM1, including our CouchDB, our Kafka, our Zookeeper, our controller, and source code themselves. And this kind of pipeline can be kicked off, can be built in a manual mode. Like we click on the build now or build now with parameters, then pipeline will kick off. So we do. I don't think we have to do any unit tests because Travis already covered that. We definitely need to test after the build and deployment. We're going to run system tests. We're going to run performance tests. We're going to run some tests to kill some invoker to see the results is still what we expected. So that's the first step. We create a manual Jenkins job which can build our OpenWhisk. Now the second step, we can think of process to automate this kind of pipeline build. And things we only have limited resource like 3 virtual machines, and the pipeline job can only run one at a time. Because if we run concurrently, the different job will mess up since we only had limited resources. And the third step, I will consider to support Kubernetes as our deploy environment. So the pipeline deploy things on top of Kube and do the test, deploy and test accordingly. And yeah, I have already touched base with some of the folks in the community. So here's a kind of general plan. And next, I will volunteer to do this type of work.
Yeah.
So that's my kind of my proposal for OpenWhisk.
Yeah, I guess Vincent, for what it's worth, I sort of feel like the Ansible stuff is a side path that you probably shouldn't go down. But go ahead. If I was doing it, I'd go directly to Kube using the Helm charts and not bother with the Ansible.
Yeah, sure. They are both on the agenda. So first, you really give me some easy steps so I can start. And they can definitely be let's say two separate pipeline. One is called like OpenWhisk Ansible. The other is called OpenWhisk Kube. Okay.
All right. Do you need any help with this, Vincent, or?
Yeah. Any folks interested? Welcome to chime in.
Any questions from anyone? Okay, cool. Thanks, Vincent. Let's go on to Dragos. You there?
All right. Yeah.
Okay, cool.
Okay. Let me share my screen. Okay. Sure. I hope you can see it. Can you see my screen?
Yep.
All right. So I just been working to enable developers to be able to start controller and invoker from IntelliJ, which I think makes it easier to debug our system. So I built on the work done by Chetan. Most of the work has been done by him, but there was an issue with the invoker, especially when we run for Mac, that the Docker for Mac does not expose a route directly to the containers. So I worked a little bit. Let's see if I can move this from my screen. Okay. So I worked a little bit to create a small Docker for Mac container factory that exposes basically the action boards on the host, so that we can run invoker from our local host and still be able to ping the action containers. And I also updated a little bit the Groovy script to work with Docker Compose and also with local Ansible. I like to echo Dave's comment made earlier regarding Kubernetes. If we get to the point where we standardize on one CI, I guess, or one way to build a project that is also respected in Travis and also in the other VMs, probably it's a good moment to think about just getting rid of the others, Ansible, Docker Compose, and everything, and just have everyone moved over to one. Having said this, the work with enabling debugging capabilities with Kubernetes is still not done. It's possible, but we have to play a little bit with the ingress ports for the database and for Kafka, and just make sure that they are exposed somehow on the host. So probably if we do that and we also figure out how to expose containers, I think we can debug locally as well. Just want to quickly, in 2 minutes, walk you through how one developer could do this. So I have Docker Compose started on my local machine. All the containers are started. So to configure IntelliJ, we have this Gradle task, which is found in Tools Dev IntelliJ, that will look at the running controller and invoker. It will inspect the environment variables and other configuration, and it will print into, basically, it will write into a run configuration in IntelliJ. Right. If I go into IntelliJ, the Gradle script wrote this invoker and controller configurations. And without further ado, we can now just go ahead and run the controller and also the invoker. Due to the poor binding on the host, it is possible to run a controller in parallel, but we have issues with database. So it's best to just stop the other containers, like the controller that was started, and the invoker as well. But if you feel courageous, you can also tweak the invoker, and you can run with a different ID, and we can have locally 2 invokers. but when you invoke actions, you don't know whether those actions will reach your invoker that you're debugging or not. So if you want to make sure that all the actions reach your invoker, it's best to just stop the running invoker and then start from IntelliJ. Right, so these are stopped, and we just start a controller and the invoker. Hopefully no surprises for this demo. Okay, I'm gonna go ahead and start invoker in parallel. I think when I run in parallel Ansible build, and I think it tries now to read from Whisk properties, which is confusing. So I may have to delete the Whisk properties just because it has different ports, I think, locally. So properties, yeah. Okay. I failed to run a flawless demo.
Blame the demo gods.
All right, this worked. And things that didn't work, the thing that didn't work before was this invoker, which now works. And yeah, nice part is that we can put breakpoints and follow the flow, which for people who are familiar with the system, this is probably not so much value because all the system is in, it's in your head. But if you're new to the system, putting a breakpoint and figuring out, what happened, what is the call stack, I think is invaluable. So you can see on my screen that the invoker started and maybe the health check action was is working right now.
This is super useful. I use it all the time for tests. Like I cannot write Scala without debugging, and because I'm not like a super genius in Scala, but I couldn't do it on a controller invoker code. So this is good.
Yeah. All right. So thanks, Carlos. That's it. Again, food for thought. We have both Ansible and Docker Compose running, and food for thought is if you want to standardize on one CI and one local setup and get rid of the rest.
Any thoughts on Cube? Thinking out loud.
This looks pretty cool. I think, Dragos, I'll follow up on you and try to look at this. I think on Kubernetes on top of Docker for Mac, it actually ought to be relatively simple to do this because all of the pods are actually also accessible as Docker containers as well.
Yeah, that's what I was thinking. The different ports, they don't collide. Yeah.
But we don't have an ingress, right, for those. Our only ingress is for the gateway, correct?
We don't expose them on the kube level, but you can talk to them via Docker.
Directly,
So I think
local Docker.
Let me see if I have here. Yeah. Okay, we can talk about it. That'll be great. There's also the internal domain name, like SVC, from the service, which we might either choose to just tell developers to put in etc hosts and map it to local host, or just to find replace in the run configuration.
Right. Yeah, that makes it. It's figuring out how to hack up the network connections to work.
Yeah.
But yeah, this looks very cool. So.
All right, that's it. Let me just stop sharing.
Okay. Thank you, Dragos. So, so this was the last meeting of the year. Please take any discussions on the dev list like we have been doing. And so Matt is going to reset the meeting invite. It's on the same timing, Wednesdays this time, but we are going to start from January 9th because next instance is on mid-December and it's pretty much close to holiday time. in US. So and then after that it's on the New Year, on pretty much New Year, 2nd January. So we are going to reset it to following week in January, and Matt is going to send out a notification. So thank you, everyone. Thank you, all the presenters, and wish you happy holidays and happy New Year in advance. See you next year.
Thank you, guys. Thank you guys for hard work.
Yeah, it has been pretty good year so far.
Yeah.
Yeah.
Have a good holidays, good New Year's Eve, everyone.
Yeah. Thank you. All right. Bye, guys.
Bye, guys. Take care.
Take care.
Bye.
Thank you. Bye-bye.
Bye.
Right.
Bye.
Bye.
Merry Christmas.